All right, so we have looked at how to find missing sides of triangles that are not right triangles using the law of sines and law of cosines. And we are going to look at how we can find the area of the triangle if we don't know the base and the height, like we've been using to find the area of triangles for a long, long time. So this is going on page 102 when we're done. Okay. Yes? No, it does not, but thank you. That means that my computer sounds don't come through. But I appreciate that. All right, so it says, what is the formula for the area of a triangle? So the area of a triangle formula that you know and have known forever is what? 1/2 base times height. Very good. All right, so that works every time if you can find that information. Sometimes you can find the information, but it's easier to do it a different way, or maybe we're not going to be able to find the height. We don't have enough information for that. If you look at this triangle right here, we have a triangle where the height is drawn in. There's the base, right? So for this triangle right here, if I want to find, it asks what the sine of C is. So here's angle C. I'm just doing regular old right triangle trig. The sine of C here would be what over what? H over A. So this would be H over A. So if I took that little equation, the sine of C equals H over A, and I solve for H, what would I get? A times the sine of C. Right? Okay, so I don't have to know the height. If I can find the sine of if I have an angle and I know the side length, then that basically gives me H. So when I substitute all that in, another way to look at the area formula of a triangle is 1/2. Instead of putting the B first, we usually put things alphabetically. So although it's going to be B times A times the sine of C, I'm going to write it as AB sine of C. Okay? So we don't have to know the height. We don't have to be able to find it. And I show you these things because if you know this formula, which you totally do, and you know how to find the sine, which you totally do, you could come up with this again if you needed to, if you couldn't just remember what it was. But because of the way that this is, when this is A, this is B, and this is the angle that it's using, that means you have to have a side angle side situation in order to use that formula. So you either have to already have the side angle side information or you have to be able to find that information. At least. Okay, so these directions say find the area of the triangle round to the nearest tenth. Well, it says nearest tenth because I forgot to change it. But remember that the rule for your decimals is 3 decimal places unless it says otherwise. And it says otherwise, so we're going to do the nearest tenth because that's what it says. Because you have to be flexible and actually, read the directions. But if it didn't say, if it just said find the area, then I would do the 3 decimal places, right? Okay, so we'll do number 1. My formula is 1/2 A times B times the sine of C. I have a side angle side situation here. So this can be A, this can be B, this can be my angle C. So I just substitute that in and I get 1/2 times 11 times 16 times the sine of 105. And then that's just a substitute and punch your buttons on the calculator and get your answer. So this would give me what? 85.0 feet squared. Everybody agree with that? And remember, on your calculator, I want you to make sure that this little letter right here is a D. I know it is tiny. I know the D and the G look very much alike, but make sure that it's in degree mode. They all should be, unless somebody changes it on purpose to be a jerk or by accident because they're just punch buttons. But, just always double check that. Okay, any questions on this? Easy enough, right? You just got to know the formula. All right, so let's look at number 3. So on number 3, I do not have a side angle side situation. I have angle angle side, so I need side angle side, which means I'm going to need to either use the law of sines or cosines to find another side. It does not matter which other side that I find. Doesn't matter at all. I can, if I have this side right here already and this angle, those relate to each other, right? And then I have this angle so I could find this side. Would I use the law of sines or the law of cosines? Law of sines. Okay, so I'm going to call this x so that I have something to call it. So I'm going to use the law of sines. That's just a proportion. So it's the sine of 76 over 7 equals the sine of 59 over x. Right. So then I'm going to cross multiply 7 times the sine of 59 divided by the sine of 76. That gets me what I called x. So what should I do with that? Store it. So I'm going to shift, store. I'm going to store it in x because that's what I called it. Is everybody okay with storing? Yes? So my x is taken care of. So I get that x was, it was like 6 point something. Doesn't even really matter. But I had stored, but I'm going to write that down. But here's the problem. I have this side now, and I have this side, but I don't have the angle that I need for side angle side, right? I mean, I can find it. It's easy to find. Just make sure that you know that you don't get to use one of these two in the formula, right? So I can find this angle, add these together, subtract from 180. What do you get from here? What do you get for this angle? 45. Good. So these are the three pieces of information I'm going to use in my area formula. Now, just as a side note here, I could have found 45 first. I could have found the 45 before I did any of that, and then I could have used that 45 to find this side over here, and I could use this side, this angle, and this side, and I'll get the same answer in the end. So it doesn't matter. You could do it differently than your neighbor, and as long as you're using the side angle side, your work will look different. Your area in the end should be the same. Okay, so then I need to put this into the area formula of my triangle, which is going to be 1/2 times x, which is I'm just going to use x out of my calculator, times 7 times the, is it sine or cosine in the formula? Sine of 45. Just got to make sure that you're using the numbers that jive with what you're doing. So I can do 0.5 times recall x times 7 and the sine of 45. Okay. And that's what I got. Is that what you got? So we're going to put 15.3, and don't forget your units, millimeters squared. Okay. Everybody okay with that? Easy enough? So got to use the formula, but you got to find your stuff first, which is something you already know how to do. All right, any questions? All right, flip it over on the back. Let's look at number 6. Well, on number 6, I don't have side angle side here either, right? So I need that. It doesn't matter which angle I find? No. If I was solving the triangle, though, which is not what I'm doing here, but just a little side note, if I was solving the triangle, then I want to find the largest angle first, because after I find the largest angle, then I could switch to law of sines. So not a bad idea just to kind of get in the habit of that when it doesn't matter what you find. We're going to find the largest angle, which would be across from 16, but it really, like I said, it doesn't matter, but we'll find theta. Call it theta. So in order to find that angle, what do I use to find the angle? Law of cosines. Good. So what goes on the left-hand side of my law of cosines then? 16. Good. So 16 squared equals 14 squared plus 6 squared minus 2 times 14 times 6 times the cosine of theta. So in my calculator, I would do 16 squared minus 14 squared minus 6 squared. And then I would divide that by negative 2 times 14 times 6. So I get negative 1/7, but that's not my answer, right? What do I need to do with that? Cosine inverse. Yeah, cosine inverse of my answer. So now I have my angle. And I want to store that angle, because you can manipulate this a lot of times where you don't necessarily have to store, but then if you have to hit clear and you start over, it's just frustrating. So we're going to store that. I'll store it in x, even though I called it theta, because I can't store it in theta. So I get that theta equals x, which was 98 something. So I've got that angle now. Okay. So now for my triangle, I need side angle side. So I'm going to use this side and this side, because I have this angle right here. So the area of my triangle is going to be equal to 1/2 times 14 times 6. Is it sine or cosine in the triangle formula? Sine. It's the sine of x, because that was my angle. So I can just do 7 times 6 times the sine of x. And that's what I get. All right. Any questions at all? We're all good? Okay. So we have another option if we know all three sides, something called Hurons Formula. And although I can show you where the other area of the triangle formula comes from pretty easily, showing you where this comes from takes a few pages of algebra work. It would take me like an entire class period to get you through it, and I don't think it would do you any good. Like the other one that I just showed you, I feel like that might be something that you could go back through if you needed to. And even though I show you things that I don't necessarily expect you to be able to work back through again, I don't know that showing you this, except the algebra that happens in it, is doable, and you could definitely follow it if you just really want to see what that is. It takes 2 videos on Khan Academy, but they do a really good job of showing you why it works. I'm not a big fan of giving you things and not showing you the why, but this is one that I don't know that it's worth it. So you can take my word for it, or like I said, those 2 videos on Khan Academy are pretty good about explaining where it comes from. But Hurons Formula doesn't even require any trig. And it's named after hero of somebody from way back when, I don't know. But so it says, when the measure of all 3 sides of a triangle are given, you can use Hurons Formula to find the area. We could also do what we just did, which was the law of cosines, and then use that other area formula. But here's what this triangle formula looks like. Area of a triangle equals big old square root s times s minus a times s minus b times s minus c. Okay, so not that bad, but you gotta know what SC is, right? So we'll talk about S in just a minute. And A, B, and C are just your 3 side lengths. So S is equal to 1/2 times A plus B plus C. So if you look at just the A plus B plus C, what does that tell you about the triangle? The perimeter. So this is half the perimeter, basically, right? So what do you think that might be called? What's half a circle called? Semicircle. So this is the semi-perimeter. That's all it is. That's okay. I got sphere last period, so. Semi-perimeter. And the semi-perimeter of figures comes up in some other interesting formulas, but all that is the semi-perimeter. Very easy to use. So if you have the 3 sides, yes, again, you could go through the law of cosines, find the angle, and then use the sine formula for that. Or we could just do it this way with Hurons Formula. So I have to start with the semi-perimeter. S is equal to 1/2 times 18 plus 21 plus 19. And what do you get for S? $29. Good. So then when we substitute that into the area formula, you get the square root of 29 times 29 minus 18 times 29 minus 21 times 29 minus 19. And you can just type all that under that big old square root in your calculator. You don't even have to actually do the subtraction, even though it's simple. If you're worried about making a ridiculous mistake on some basic subtraction, you know, not a bad idea, just type it all in. But remember, if you're using a calculator that doesn't have the square root that follows you, that you're going to have to use some extra parentheses there. So even though the formula is weird, it's really not that hard to remember what to do with it. Once we type all that in, it wants to give me what the answer is. Okay, but how are we supposed? That's okay. These directions said the nearest tenth, so 0.7 is okay. and then miles squared. Very good. All right. Any questions at all? Okay. Your assignment only has 4 questions because you don't need to do 1,000 of these, right? But the directions here, all the directions say are find the area of each triangle, period. So how many decimal places do you go to? 3, because it doesn't say, right? So when it doesn't say, you go to 3. When it says, you do what it says. Does that make sense? It's one of the things you kind of got to get used to. All right, so go ahead and glue or tape this in.